All right. Um, so I think we'll start by writing down the steps that we normally use, okay? So I'm going to write down a system, then we're going to solve it by substitution. Okay. So this is going to be our example, then we're going to do a few of these together. Let's say we have a simple system. X equals -2. So if we're graphing this, that would be a vertical line, okay? Then we have a second equation, because we need two, and that's this one, x plus 3y equals 4. All right? And we want to know what combination of x and y numbers would be work in both of these. Okay? We were solving this by graphing. Now we're going to use substitution. And this is what we do. So the first step, we'll call these steps, are the following. We're going to isolate one of the variables. So we're going to isolate one of the variables. Second step. By the way, in most of our inequalities, at least in Math 8 level, one will already be isolated, if not both. Well, if yeah. Second step. This is called the substitution step. Substitute into the other equation. Okay. We'll explain as we're working what that means. Step 3, there's 4 steps. Solve your new equation. And the last step, we're going to have to substitute one more time. To get the value of the original variable. Okay. So we're going to practice most of these steps on this first equation. But by the time we're done with the other 4, we'll see all of this. Okay? So the very first step, isolate one of the variables. We don't have to do it in this one, but I want everyone to see. Do you notice our first equation on top just says x and nothing else? It says x equals. That's what you want. You want one variable isolated all by itself. If you notice the second equation, neither x nor y are isolated. We got an x and plus 3y. We have both of those things, okay? All right. So what I'm going to do is I'm going to take this one that's already isolated, and I'm going to take what x equals. X equals -2. And one thing I'm allowed to do is take that -2 and substitute it in for x in the second equation. So I'm going to rewrite this equation below. but I'm not going to have x anymore. I'm going to have negative 2 in its place. Let's do that. So it's going to be negative 2 plus 3y equals 4. Okay? This is a two-step equation. We've solved a bunch of these. Okay? Let me refresh your memory. Go ahead and write that down. So I'm going to get rid of negative 2. I get rid of the constant, then I get rid of the coefficient. It's one of those equations. So what's the opposite of negative 2? Positive 2. So I'm going to put a positive or plus 2 here. And I have to do that to the other side of the equation. So underneath the 4. Okay? So we're just solving a two-step equation. Okay? Okay, write that down. All right, moving on. We're almost there. Let's get rid of the 3. It's 3 times y. How do I get rid of just the 3 and not the y? Divide. If I do that, then I have just a y on the left, and on the other side, 6 divided by 3, which turns out to be a nice answer of 2. Okay? Now, normally, we would take this answer y equals 2 and go back to our original equation that we substituted with to figure out x. But we're lucky this time. If you notice, we already have the answer for x, so we can get our solution. Solution is still going to be an ordered pair. We have to figure out the value for x and the value for y, and we got both of those. Okay? So we want x and we want y. What does x equal? Negative 2. We got lucky and they gave it to us. And we just figured out what y is. Y is 2. Okay? Let's continue. So we're going to do 4 of these together. I want to give you a sense of the type of equations you'll see. All right. So let's write down the 2 equations for the next system. Y equals 2x, and x plus y equals 9. Yeah, 1 second. And we're going to start by substituting. Do we have an equation that says x equals or y equals? You see one? Y equals 2x. We're going to use this one to substitute. So where it says isolate, it's already isolated for us. Look for that. You're going to see one all the time. So I'm going to take what y equals. Y equals 2x. This part here. And you're allowed to replace in the other equation, in place of y, you put in 2x. That's what I'm going to do. So I'm going to rewrite this equation. But instead of x plus y, it's going to become x plus 2x equals 9. And you may be wondering, because I used to wonder this too when I first learned this, this looks harder. It has more stuff. Why are we doing this? The reason is I can't solve an equation with 2 different variables, but I can solve an equation with one type of variable, in this case x. So now let me go ahead and solve it. Do you notice I can combine? What's x plus 2x? 3x. So all of this dilutes down to 3x equals positive 9. And I could solve that. Just divide both sides by 3. You see that? And now 3/3 cancels. I get x. And then I have 9 divided by 3. Fortunately for me, that divides evenly. I get 9/3, which is 3. So I have one of my answers. I know what x is. It's 3. I don't know what y is, but I could figure that out real simple. So I'm going to make another column here to do a little work. And you see this equation that I started with y equals 2x? Let's take it. This is going to help us figure out what y is. Right now I'm saying y equals 2x. But what's the value of x? How much is x, guys? X equals 3. So now I'm allowed to substitute in 3 anywhere I see an x. And I'm going to substitute it in here. So instead of y equals 2 times x, it's going to be y equals 2 times 3. Okay, that's why this is going to help you find out what y is. So what's y in the end? It's 2 times 3. And that's 6. So we know what x is. We know what y is. Let's write down the solution. What's my ordered pair? 3, 6. So without graphing a single line, I could figure out where those two lines cross. Any questions? Okay. No questions. Okay. Let's move on to number 2. So for number 2, it's going to be y equals 6x plus 10. And then our second equation is y equals 4x. So go ahead and write that down. Y equals 6x plus 10 and y equals 4x. Okay? And we want to figure out where these two lines cross without graphing. First thing we want to do is look for a variable that's isolated. That either says x equals all by itself or y equals all by itself. Do you notice we have two of them? We have y equals 6x plus 10, and then we have y equals 4x. They're both basically in this slope-intercept form. So we have a choice. Do we plop in 6x plus 10 into the second equation, or do we plop in 4x for y in the first equation? What seems easier? Do you want to deal with 6x plus 10 or just 4x? What do you think? What seems easier? 4x. Yeah, I would do 4x in there. Okay? So that's the first thing we're going to do. Y equals 4x. So this 4x is going to go here. Okay? Let's do it. We're going to rewrite this. Okay? So instead of y, I'm going to put in 4x equals, and then the right side, 6x plus 10. So we have an equation. We have variables on both sides. Let's solve it. So we're going back to solving like equations like we did at the middle of last semester. Okay. So I notice I have 10 on the right. But I want to leave that there. So that means I want to get rid of this 6x. The whole 6x has to be removed from this right side of the equation. What can I do to remove 6x? I'll give you a hint. What's the opposite of 6x?
Positive.
Well, right now it is positive. Yeah. There's a catch. I can't put a negative 6x on the right side of the equation. But if I do that, I have to do that to the left side. So if I put negative 6x here, I got to put negative 6x here. Okay? And let's see what happens. So right now they're equal, which is what I want. Write this down. Write this down. Okay. So first of all, 6x and negative 6x, they make 0. They're gone. And now on the other side, I have 4x minus 6x. That's negative 2x equals 10. All right. Do me a favor. Divide both sides by negative 2. Because I don't want that negative 2 with x. I want it gone. So divide it out. And I get x equals, well, 10 divided by negative 2. Negative 5. So I got the answer for x, negative 5. The x part we know now. It's negative 5. Okay. So let's see. I'm going to do the rest of the work right next to it over here. I want to figure out the y part. Look at this. I have two equations I can substitute with. Y equals 6x plus 10 or y equals 4x. Which one should we use? 4x. It's smaller. It's less. Absolutely. So over here, instead of y equals 4x, we're going to make this y equals 4 times what x equals, negative 5. So let's all write that down. Y equals 4 times, we don't want x anymore. We know what x is. It's negative 5. And that would give us our answer. What's 4 times negative 5? Okay. And now we have our solution. We know what x is. We know what y is. Let's write it down. Solution. Solution is, for x, it's negative 5. That goes first. For y, it's negative 20. There you have it. Okay. Now tomorrow we'll see more systems like this one, where they're both y equals or x equals. Hold on. All right. Got two more. These are going to be a little different. Okay, write this down. Y equals 2x is one equation. Negative 6x plus 3y equals negative 5. Yes? No, not right now. All right. Let's substitute. So I already have one equation that says y equals in this case. So I'm going to replace y with 2x. So you see in the second equation where it says plus 3y? Well, I'm going to replace that y with 2x. Let's see what that looks like. Negative 6x plus 3 times, not y, but what x represents, 2x, equals negative 5. Okay? Go ahead and write that down. So this is a substitution step. You're replacing y with 2x. And now let's simplify it. I got negative 6x, that's fine, plus 3 times 2x. How much is 3 times 2x? 6x. We're multiplying. Yeah, someone's noticing. Next, I should combine those since they both have x. But negative 6x and positive 6x, since they're opposites, they make 0. And something very different happened. I end up with all the x's eliminating. And I end up with a statement. 0 equals negative 5. Mm, hmm. What does that mean? What does that mean? We've come across this before. Is that true or false that 0 equals negative 5? False. It's not true. 0 equals 0, negative 5 equals negative 5. So this is a false statement. It's a false statement. And whenever we end up with a false statement, that means, therefore, no solution. So in these systems, what does it mean when there's a no solution? What do we have as graphs? Remember? It's not going to be 2 lines across. That would be infinite solutions. These are parallel. So these are parallel lines. But all you really need to write is no solution. If you end up with some nonsense like negative 12 equals 0 or something like that, it's a no solution. Okay? Any questions? You'll get one or two of those today. All right. Last one. Let's do x equals 7y. X equals 7y. And x minus 7y equals 0. Okay. Go ahead and write that down. X equals 7y is 1. And then x take away 7y equals 0. So we do have something that's isolated, right? X equals. We look for that. And then we're going to replace 7y in place of x. Okay? So let's do that. Replace this x with 7y. So here we go. 7y take away 7y equals 0. Do you notice it cancels again? All of this becomes just 0 equals 0. Is 0 equals 0 a true or a false statement? This one's true. This is a true statement. This one was false. Therefore, we have infinite solutions. And these are the overlapping lines. But the only answer you need to state is infinite solutions. Okay? All right. So this is what we're going to be doing. There's like 9 of these that we're going to do. Okay, I'm going to pass them out. So above, it gives you an example all worked out, including step 4, which we didn't talk about, where you check to see if you got the right answer. But we won't worry about that. The only thing we are going to do is the substitution to solve. So look for something that says x equals or y equals. Replace it into the other equation. So since it says x equals 5, I'm allowed to put in 5 for x in the second equation. So now I'm going to write this as 5 plus y equals 12. And it's a very simple one-step equation. Get rid of the 5, you get your answer. And I end up with y equals 12 minus 5, which is 7. So now I know what y is. And if you notice, I already know what x is because they gave it to us. So for the solution for this one, it's 5, 7. Okay? And you have a couple more just like that. Number 4 is a little more difficult. I can play around with that one. You tell us y equals 2x. So wherever I see y in the other equation, I can plop in 2x. And then I can, in this case, I can combine. I got x plus 2x, adding those together. I get that. Okay. Okay, so I gave you a little help. We did number 1 completely, and number 4, we got you halfway through it. So go ahead and continue.